Hello folks, you are welcome. Let's solve this question. Instead I should calculate the angles ABCD. So what are you going to do? First of all, you have to analyze your question carefully. You realize that this question is a circle theorem question. Meaning you need theorems of circles to solve this. So you ask yourself, which of the theorems are applicable here? So looking at this carefully, you realize that alternate segment theorem is applicable here. So let's do that. So solution. So the one we are going to use to solve our A is the alternate segment theorem. It states that when there's a tangent and a chord, the angle between it is 65 degrees. It should be the same as the angle that subtends the chord. Subtends the chord, meaning from the end point of the chord, drawing line which will touch the circumference. The angle found there should be equal to this angle. That's the angle between the tangent and the chord. So A will be equal to 65 degrees. So our A is equal to 65 degrees. After doing that, then move on to our B. Since this is a triangle and we are gotten our A, then we can find what? Our B. So angles in a triangle sum up to what? 180 degrees. So right, angles in a triangle add up to 180 degrees. So what are the angles? A plus 45 degrees plus B equals 180 degrees. A is what? A we have 65, so 65 degrees plus our B is what? 40. And we don't know our B, but we know 45 degrees here, plus B equals 180 degrees. 65 plus 45 is 110. 110 degrees plus B equals 180 degrees. Meaning our B will be equal to 180 degrees minus 110 degrees. Therefore, our B will be 70 degrees. As simple as that. So we have gotten our A, we have gotten our B. Our next move is to get our C. The C also, the theorem that comes in mind is when you have two tangents, this one tangent, another what? Tangent, meeting at a point, they are meeting here. In that case, the length of this tangent and the length of this tangent should be equal. If two lengths are equal, it means that two angles are also equal. So meaning the base angle of this triangle, which is isosceles, should be equal. So this is 65 degrees. Automatically this one should also be 65 degrees because it has equal length. So this is also 65 degrees. If you get this, then you can get your C. So how are you going to get your C? You are going to sum this up, then you equate it to 180. So 180 degrees will be equal to 65 degrees plus 65 degrees plus C. 65 plus 65 is 130. So 180 degrees is equal to 130 degrees plus C. Our C will therefore be 180 degrees minus 130 degrees. So our C is 50 degrees. So now your C is 50 degrees. Very good. Now let's move on to D. How are you going to get your D? Looking at this carefully, you realize that there's a quadrilateral in this circle, and the quadrilateral is touching the circumference of the circle. This is quadrilateral, one length, another length side, another side, another side. 4 sides. So 4-sided figure quadrilateral is touching the circumference. So you are going to use what is known as the cyclic quadrilateral. It states that opposites opposite angles of a sighted quadrilateral should sum up to 180 degrees. So D plus 45 degrees should give me 180 degrees. But in this case, I'm finding D. So 45 degrees plus D should give me 180 degrees. Let's do that. So opposite angles in a quadrilateral should sum up to, or should add up to 180 degrees. So therefore, D plus 45 degrees should be equal to 180 degrees. So D is equal to 180 degrees minus 45 degrees. So my D is therefore 135 degrees. Very easy.